Hey everyone, my name is Brandon and welcome to Finance. So in this video we're going to be talking about hypothesis testing, the methods involved, and how to generate a hypothesis from data. So let's get started. So what exactly is a hypothesis? Well, a hypothesis is something that we're trying to examine. It's a question that we have about our data set, and we want to test to see if this thing is happening in our data. And in order for us to run a hypothesis, we have a few assumptions that we are going to make. The first assumption is that we have a normal distribution curve. Now, we don't always have to have a normal distribution. There are tests that you can perform to account for this. However, it's a little bit beyond the scope of this video. However, we're going to assume we have a normal distribution if we have 30 or more sample tests. So we have 30 or more units, and that's going to be based off of the central limit theorem. Now, all hypotheses you ever make will always be based off of sample data. Sample data is simply just data taken to represent an entire population. So let's say that you wanted to test that all brownies had walnuts in them. Well, you can't do that because you physically can't check and see every brownie around the world. It's impossible. So what you'll do is you'll walk around to 40 different bakeries, eat some brownies, and say, hey, do these have walnuts in them? I don't know. And you're going to use that information that you collect to represent the entire population of brownies. So you'll notice if we have a normal distribution curve, we have this shape in the bottom, and it looks kind of like a bell. And this is really a beautiful thing. We could get so much information from this curve. The first thing I'll point out is that it's centered around the population mean. And what this basically means is 50% of the data will be on this side and 50% will be on the other. This means that every point, if you summed up every point underneath this curve, it would equal 1. That means we could draw probabilities from it and make better inferences around this curve. Another thing I want to point out is that, and I'll touch upon this a little bit later on in the video, is that if we were doing a one-tailed t-test, we would examine one half of this curve. So we would look on the left or the right-hand side. Whereas if we were doing a two-tailed t-test, we would look at the entirety of this curve. And this is going to be important when we discuss p-values to determine if our hypothesis in the thing we're examining is significant. So let's figure out how to actually create a hypothesis and the steps that are involved. The first thing I want to point out is that this is going to be the same formation that you use for every hypothesis. I want you to use these 4 steps for every hypothesis that you make. Secondly is remember, your hypotheses are from sample data. So if you add or remove any samples, you're going to get different information. So it's always going to change the more you increase or decrease your samples. The first step I want you to do is to create a null and alternative hypothesis. So a null hypothesis is going to be the thing that you're testing, and it's always going to be equal to something. It will never not be equal to something. So remember, always use an equal sign. The alternative hypothesis is the opposite of your null hypothesis and can have 3 different signs. So it could have a not equal sign, it could have a less than or greater than sign. And remember, when you're using a not equal sign in your alternative hypothesis, you are using a two-tailed test. So remember that bell curve, and remember with a two-tailed test, you're checking the entirety of that curve, so every information point underneath that curve. Secondly, if you're using a less than or greater than symbol, you are using a one-tailed test, so you are only looking at half of the information in that curve. The second step I want you to do is to examine your test statistic. And that simply is just a measurement of the difference in the means relative to the variability. So the greater the difference in the means and the smaller the scatter in your data, the bigger the absolute value the t-statistic or the test statistic will have. And we're going to look at two ways of calculating this. And this is going to be using a one sample and two sample with equal variances. So when you have one sample, it's just simply going to be the sample mean minus the expected value divided by the standard error of the mean. And if you're using a two sample equal variances test, it's going to be the sample mean of sample 1 minus the sample mean of sample 2 divided by the square root of the standard error of sample 1 squared plus the standard error of sample 2 squared. Now, there's also a test you could run for two samples with unequal variances. Just know that we're not going to go over that in this video. So this is for equal variances. This third step I want you to do is the easiest, and that is to determine your significance level. And you could either have a significance level of 0.05 or 0.01. If you choose a 0.05 significance level, you are saying that you are 95% certain or confident that your data, your thing that you're testing, is underneath that curve. If you are using a 0.01 significance level, you are saying that you're 99% certain that your data is underneath that curve. So that is what you're testing. However, though, you're always going to have the chance for an error. And a type 1 error is rejecting the null hypothesis when it's true, and the type 2 error is accepting the null hypothesis when it is actually false. So know that you're always going to have a chance for creating a type 1 or type 2 error. It's just going to change on the chance if you have a 0.05 or 0.01 significance level. But you get to decide which one you're going to have for your data. The fourth step is examining your p-value. And what your p-value tells you is how significant your data is. So it's almost like a chance of seeing how true, how representative your data is of the population mean. And a few things I want to point out here. When you're running a one-tailed test, you are looking at 1/2 of that bell curve. So it makes sense that you need to divide your p-value in half to be representative of the test you're running. Whereas if you're doing a two-tailed test, you're looking at the entire curve, and that is when you leave the p-value alone. So I mentioned a few things in here. I mentioned standard errors, I mentioned p-values. Well, how do we actually calculate this? Well, you're going to use SPSS or Excel most likely, and that information is going to be populated for you. So don't get too worried on how to actually calculate that. Let a computer do the hard work for you. So let's look at how a null hypothesis and alternative hypothesis are generated. They're almost identical, just going to be slightly different. So you'll notice it says H subscript 0, it's 2 semicolons, followed by the population mean of X, equal to something. So note it says equal to something for the null hypothesis. The alternative hypothesis is going to be H subscript 1, again that population mean, and then it could be not equal, greater than, or less than the thing that you're testing. So know that for an alternative hypothesis, you have 3 choices you can choose from. So here comes the fun part, actually figuring out how to use a hypothesis. And the question we have is, you want to test if males and females both like apples equally. And after surveying 40 males and females, you find the following information given in the table. So how would you test to see if males and females both eat the same numbers of apples? Well, before we take a look at the data, there's a few things I want to point out. The first thing is we know that we have 2 samples in this data. this being males and females. So we're going to run a 2-sample test. We also could say that our data is normally distributed per the central limit theorem because we have more than 30 samples. In this case, we have 40 males and females. So taking a look at the table now, let's understand how this was first calculated. So what I did was I ran a test using Excel's data analysis toolkit, and I ran a 2-test assuming equal variances. So going back to the formula we just learned, we're going to be using the equal variances formula when we calculate our test statistic for 2 samples. Looking at the means of apples for male and females, we see that men are eating more apples than females. Now, just looking at our data, we can't say this is always the case. We're testing to see, do they actually eat the same amount? The variance was found to be 1.68 and 0.99 for males and females, and the standard deviation was calculated by taking the square root of your variance. So 1.68 would be taking the square root of that to get 1.29, and females are going to have roughly the same because it's basically taking the square root of 1. The standard error was found by taking the standard deviation, so 1.29, and dividing it by the square root of 40, so the number of observations that you have. And if you do that, you'll get 0.2. Same thing with females. You take the standard deviations of 0.99, divide it by the square root of 40, and you will get 0.16. The pooled variance of this combined data is 1.33. We set our hypothesized mean difference to be equal to 0, so that the mean is basically saying the mean is the same. The degrees of freedom was calculated by adding up 1 minus the number of samples you have for each category. So what that means is you simply do 40 minus 1 for males, 40 minus 1 for females, and add them up and you will get 78. The test statistic was a little bit more difficult to find, and we'll go over how we calculated that in a few seconds. The next thing I want to point out here is we have a p-value and a one-tailed test. If you look down a little bit, you'll see we have a p-value, and that's for a 2-tailed test. And the thing to point out is for the 2-tailed test, you'll see that it's 0.62. If you look back up here to the one-tailed test, you'll see it's 0.31. That's exactly half of 0.62. So the one-tail is if you're looking at only half of that bell curve, whereas the 2-tail is if you're looking at the total curve, and that's why it's 0.62, and that's why it's half for the one-tailed test. So let's figure out the steps that we had in order to run this test. And I'll just show you all of them because it'll be easier to explain. So step 1, and that's determining your null and alternative hypothesis. In this case, we said that men and women both eat the same number of apples. So in that case, we have to subtract them, and we're saying that it's going to be equal to 0. That's because men and women, the population means, are going to be equal. Our alternative hypothesis is we're saying that no, they're not equal. Men may eat less or they may eat more apples than women. So that's why they're not going to be equal. And notice we have a not equal sign. That means that we are going to be using the 2-tailed test. We are using the 2-tailed test, so we're using the p-value of 0.62. Our test statistic was calculated using the formula we just saw, and using 2 samples assuming equal variances, and that was found by doing the sample mean of men, so 1.65, minus the sample mean of females of 1.52, divided by the standard error of men, so 0.2, squaring it, adding it to the standard error of sample 2, so females, and squaring it, and then taking the square root of that sum. If you do that, you'll get 0.49, And that makes sense. That adds up to our test statistic of 0.49. Step 3 was the easy one. You set that. It could either be 0.05 or 0.01. In this case, we're using 0.05, so we're saying our population mean, we're 95% sure that our population mean is underneath that bell curve. In step 4, that's simply looking at your p-value. So in this case, remember we're using a two-tailed test, so we will use 0.62. And the next part is just deciding, well, do we accept or do we reject our null hypothesis? Well, in this case, we're going to accept the null hypothesis that men and women eat the same number of apples. And how we know if we accept this is by looking at our p-value. If our p-value is higher than our significance level, then you will always accept your null hypothesis. If it's less than your significance level, then you will reject your null hypothesis and accept the alternative hypothesis. So how I always remember this is if your p-value is less than your significance level, then you lose. So if it's less, you lose. If it's higher, like it is in this case, you accept. And how I want you to write your answer to this question is being very precise and using the data that you have in that chart or that table. So therefore, according to the table, with the degrees of freedom of 78, a t-statistic of 0.49, and a p-value of 0.62, there is enough evidence to suggest that males and females eat the same number of apples. I want you to be that specific. Don't just give me the p-values, and don't say that this is what's going on. Use that information that you have and give yourself a precise and specific answer. Also say that you're accepting the null hypothesis or that you're rejecting it. Don't just state the assumption, state everything that you're doing and be that precise. And ultimately, finding a hypothesis is just this simple. You're going to follow the same 4 steps for every single hypothesis you do. I know I gave you a lot of information in this video, but it's just going to take some practice, but I know you can get it done. So as always, thank you all for listening, and if you have any questions or comments, feel free to drop them below, and while you're there, give me a like and subscribe. Thanks again, and hope you all have a great day.